What's going on, guys? Welcome to my YouTube channel. My name's Lenny. If you've been following along on my channel, thank you very much. If not, I'm turning this wonderful cargo trailer that I'm currently in into a tiny house. It's coming along great, and I got a big video for you guys today. We're talking electrical. Let's get right into it. All right, so I'm going to try to explain a bit of the electrical before I dive into the video here. First of all, designing the electrical system was a huge step. So there's a lot that goes into this, but I'll just break down the very basics. And I do want to put a little disclaimer on this. I'm by no means an expert or an electrician, so this is kind of just what I did, and so far it's worked pretty well. So take that for what it is. The first step in designing an electrical system from the ground up for a mobile, tiny house, RV, whatever, is to figure out your loads and how much wattage they pull. So you basically need to look at everything you have that's going to be using electricity. And then you need to calculate how many amp hours a day each one of those loads is going to be using. And then you need to sum those all up. Once you get your loads all set and you figure out how many amp hours a day you plan to use on average, you basically say, all right, I want my battery to last without charging for X number of days. That's how you figure out how big of a battery you want and how much cushion you want for, like, oh, I'm off grid and it's cloudy, so I can't charge. Speaking of charging, there's a number of ways you can charge your battery when off grid or on grid. So the most obvious way is just plugging into an electrical hookup or an extension cord, an outlet. So that's called your shore charger. So I did one of those. The next most obvious way, I would say, is solar. And the last charging method that I did is a DCDC charger. So that pulls 12 volts straight from my car battery, which is generated from the alternator while I'm driving. And that charges my house battery while the car is running and while I'm driving. So you, of course, need to size all of these chargers. So you figure out how big your battery is and how many amps you want to pull into your battery. That determines how fast your battery charges. So your solar is also an aspect there. You need to figure out how many watts of solar panels you want on your roof for how fast your battery charges. This is all math that you can find workbooks online and guides that take you through the math. So I'm not going to get into it right here. And if you want me to do a more detailed breakdown of all of the math and the details, I'd be happy to do that. Just leave a comment and let me know. And then for your 120 volt loads, you need an inverter. So inverters are rated based on wattage. I personally went for a 1500 watt inverter. So now I've got all my big units figured out. I've got my battery size, my solar panels, my 3 chargers, and my inverter. So those are the big units. You figure out those first and all the numbers associated with them. The next step is to figure out the specific units that I want to purchase. This involves just researching online, figuring out what's in your price range. And then what I personally did is I bought all the units, measured them with a tape measure, and I modeled them in CAD. And then that way I can put them in my CAD model and figure out where they're going to physically fit in space, and organize them into a contained little box.
So this is what I came up with for my electrical box. We'll run you through it from left to right. So starting in the back, you can see my shore charger. Then this is my solar MPPT charger. I have my inverter on the back wall in the right. And then my DCDC charger, also called a B2B charger, on the bottom. Right here in the bottom right, you can see my big battery. On the right wall, I have my fuse boxes. These will be 2 fuse boxes that will hold 12 fuses each for 12 volts. Then in the front left, we got my breaker panel. So these over here are all my breakers. And then on the bottom front, you can see my bus bars. The next step here is to get this thing built. So I just used 3/4 inch thick plywood that I had laying around and screwed together a little box here. You can see me installing the breaker panel on the left, and then the strips of wood on the right are to enclose the battery.
Progress update from the battery box. We got some stuff in. All right, so on the left, we got my shore power. This is my solar charger. This is my inverter. And these are my fuse boxes. Oh, and I cut holes for the breakers. Apparently, so these are the breakers I bought. And I thought they would just mount flush, but like you see this huge box has to stick through. So I had to drill all these freaking, or just cut all these holes, and this one's way too big. I think this one's better. Yeah, that's a pretty nice one. But yeah, so this is where all the breakers are gonna go. Gonna have my whole line of breakers there. Let's do it. So update on where I'm at with the electrical. This is 1 out of 4 solar panel wires coming straight out of the ceiling there. I got some of my cables. I started to crimp lugs, terminals on the end of them. Got some of the fuses in, started to do some of that. Still have a long way to go here, but you know, making progress. Got all my breakers installed over here. Got my little fuse box there. It's coming together. Let's see how far we get today.
And so once my units were installed, it's just making and connecting wires.
All right, just making a quick video to show you guys my process here. So this is an 8-aught wire, and essentially I already stripped one end, but essentially what you do is you just cut this shit down to length. And then, so I got these. These are Apollo Propex plumbing tube cutters. But they cut wire better than anything else I've found. So like definitely use these. And they also work pretty well as a wire stripper. Honestly, a dedicated tool would be better. But like I just go like this and I squeeze a little bit and then I rotate. I hope that focus is working. And I just spin it, and like depending on how hard I squeeze is how deep the cut goes. It has been a pretty annoying process because if you go too deep, you start cutting the copper strands. You cut that and you see it's cut and kind of separated now. Okay, so now we have 2 bare ends, and I basically just line up where the lug terminal needs to be. So I've got these ring terminals. They need to be sized based on the ring diameter and also the wire size. So this one is an 8-aught for 5/16 ring terminal, and I just put it on like so. And then come over to my little setup over here. Got this set up on some 80/20. This is just a lug crimper. Set that up on a nice hard, firm, solid surface. Stick your lug in. You make sure the wire's all the way deep in there. You just whack it a few times. And voila, we are crimped. Come back over here. Grab the right size heat shrink. It's the wrong size heat shrink. Right size heat shrink. Get that on there. Cover it up nicely. Let me take my heat gun. If you think this is the best way to get heat shrink to shrink, leave a comment telling me that my methods are professional and excellent. Gas here. Not too many more to go. All right, that's good enough. Heat shrunk nicely, and then that is my MPPT solar charger. Make sure I put this in the right place. PV negative is the right place, and then this just scoots right up in there. like that. Tighten it down. This will just go there, like that. But I need 2 more wires hooked on there for my other solar panels. And yeah, I basically just spent hours and hours and hours just measuring, cutting wire, crimping lugs, and connecting all these things up. Check it out, I made a mess here. We got some holes drilled. We got this hole for the solar wires, the big hole for the 1500 watt inverter. That's where the, can you see? That's where the plugs are. So just like regular ass plugs will go straight through there. And then I did 2 holes here because these are my fuse boxes. So wires are gonna come straight out of here and just get out of the electrical box and go down there. Oh yeah, and last but not least, that hole is for my DC charger. So it's gonna route right around the battery and back through there. A bit of a rat's nest right now. That's mostly just my solar cables. Without those, it's pretty good. I'm gonna throw some zip ties on the walls, and most of this stuff's hooked up. So we got a pretty good setup here. I'm gonna also use these and just run them straight through the bottom of this box to attach this whole box to the floor. You can see we got, it's nice and captive in this rail, but it could still move. It could still slide backwards towards my vacuum. So I'm gonna just screw that right into the floor. All right, on the roof of the trailer, if you can see that, doing my solar panel wiring finally. I just pulled a bunch of ice off of this. This was a puddle. You see some water there. These things I bought and installed like a month ago for the solar panel wires. They're like waterproof rated and whatever. You can kind of see how they work. They got like little doodads and the wire goes in there. These holes I just drilled, those holes, because there's actually a nut on the back side of each one of these. And you need to like tighten this nut on the front side and hold the nut on the back side, but obviously holding the nut on the back side wasn't possible because I already did all this beautiful sealing work. So I just drilled a small hole and I'll seal that back up, whatever. So I'm running these solar panels in parallel. And in order to do that, I need a complicated series of splitters. So essentially, these 2 panels are going to be split down first, and then they turn into these 2 wires, which go in 1, 2. So that's going to go in there. The 2 smaller panels, that one and this one, these are the splitters for those. So I'm going to run a wire from that panel over into this splitter. That's the positive. And then here's the negative splitter. So these are called MC4 connectors, and these are what the splitters look like. They're pretty simple, you know, 2 in, 1 out. And yeah, so this, I need to make a small wire and put some MC4 connectors on it. It's about 4 feet long or whatever to go from that panel to here. And then I need to get another wire that'll come out of both of these and go in here. And then I have more fuses down in my electrical box for these. So this is there's 2 fuses up here on the roof. Scratch that. There's 4 fuses up here on the roof. 1 on each solar panel directly on the output. And it's just an MC4 fuse. 15 amp MC4 fuse, straight in line, straight out of the output. Then I'm doing a 30 amp fuse on this red wire. So this is doubled already. So it gets a 30 amp fuse in the electrical box. And then you can see right here, that is the 30 amp fuse box, and I have 2 30 amp blade fuses inserted into it. So we have the 2 wires coming in from the roof. So those are those 2. And then they get split down into a single wire
that runs out of the fuse box and up into my 60 amp breaker. And then from that breaker, we head to the MPPT.
All right, I'm hooking up my solar cables. I thought I'd show you guys what I'm up to. So these, you see this? Yeah. These are MC4 connectors for solar panels. They kind of plug in like that. I won't do it because you kind of got to pinch them. It's difficult.
I'll spare you the details, but essentially you have to get some special crimpers to crimp an inner piece onto the end of your wire, and then you install this waterproof outer housing on with a number of steps that prove to be a little tricky. So that's how you make MC4 solar cables.
All right, I just fired up my battery and some of my electricals for the first time. Very exciting. This has been a crazy process. Not exactly sure what I showed you guys last, but I don't think I've shown you this. So I got my bus bars screwed in, and everything's locked in there, nice and tight. I got my main switch coming off the battery right here, going straight over to the bus bar. And then everything else is hooked up in here, except for the DC to DC charger. Waiting on that one for a little bit because connecting it to my car is a little complicated. So one thing I just did, if you look over here, these are my grounds. So this right here, chassis ground, that's one of those right there. I'm not gonna reach in and touch anything because it's all alive right now. And then this is the ground for my inverter. I think 120 volt ground is supposed to be not right next to your 12 volt chassis ground, so I put them like that. But yeah, my inverter's working. I just, here's a little remote for it. Turns on, it says I got 4 bars of battery. And then I plugged my computer charger into it because it has this light on the computer charger. So now I know that it's actually pulling power. And the MPPT turned on and didn't do anything weird, so I know that works. And then the DCDC charger, hold on, let me flick that breaker. It's plugged into an extension cord right now. And there we go. That's power going into my battery. Just wired in my first thing to my fuse box. Yeah, you saw me wire these up, but I just attached a load to them and it works. So it's this white wire, goes all the way up here, over to my fan. I need to tuck this all up when I do the ceiling, of course. But fan, pulling air. Very exciting. All right, that's enough for today. I'll do another video where I show all of the electrical loads, like lights, outlets, all that 12 volt and 120 volt stuff. And then I'm also going to do another video exclusively for the DC to DC charger, because that was a whole thing in and of itself. So keep an eye out for those videos coming soon. Toss me a like and a subscribe, and thanks for watching.